In today's illustration, we will work with Neostringeria macropa, also known as the Sabanero crab. And the first thing is, what on earth is a crab doing in the mountains of Bogota? Or, before anything else, what is a crab? Crabs belong to the clade of arthropods, that large group of organisms characterized by exoskeleton, bilateral symmetry, and an impressive diversity in shape and function. Within the arthropods is the subclade of crustaceans, which includes species adapted to both marine and freshwater environments. Crustaceans are a subgroup of the phylum of arthropods characterized by having a chitinous exoskeleton, segmented bodies, and articulated appendages. Mostly aquatic, these organisms exhibit great morphological and ecological diversity that has allowed them to colonize marine as well as freshwater and even terrestrial habitats. Among their main groups are the decapods, such as crabs, lobsters, and shrimps, recognized for having 10 legs, the isopods, which range from small benthic organisms to species like the pill bug, the cirripeds, famous for their ability to adhere to hard surfaces, and the amphipods, with laterally flattened bodies and a notable distribution across various ecosystems. The decapods are an order of crustaceans characterized by the presence of 10 legs, hence their name, from the Greek deca, meaning 10, and pos, meaning foot. These animals have a typical body organization that includes an anterior part fused into a cephalothorax, protected by a shell or carapace, and a posterior part elongated into the abdomen. Their morphology and physiology have allowed them to adapt to a wide variety of habitats, ranging from deep marine environments to rivers and freshwater bodies, displaying an astonishing diversity in size, shape, and behavior.
Among the most representative clades of decapods, two large groups stand out, the Dendrobranchiata and the 𝐜𝐫𝐚𝐼. The Dendrobranchiata, commonly known as prawns or shrimp, are characterized by their branched gills and their mode of reproduction, in which the females release eggs into the water. On the other hand, the 𝐜𝐫𝐚𝐼 group includes most decapods such as shrimps, crabs, lobsters, and others that exhibit plate-like gills and an embryonic development with parental care. This group is also distinguished by the morphological and ecological diversity it presents, allowing for species to exist in almost all aquatic and terrestrial environments on the planet. The 𝐜𝐫𝐚𝐼 constitute a subgroup of decapods that includes most species, characterized by embryonic development in which the eggs remain attached to the female until hatching, allowing for greater parental care. Within this broad group, the Brachyura, commonly known as crabs, stand out for their distinctive morphology in which the abdomen is reduced and folded under the cephalothorax, adapting to a wide variety of habitats from marine environments to freshwater bodies. This morphological and ecological diversification has allowed the Brachyura to evolve into numerous species with essential roles in ecosystems, demonstrating a remarkable capacity for adaptation and specialization. Crabs typically move sideways, a movement referred to as crabwise, due to the articulation of their legs that favors more efficient lateral locomotion. However, some species, such as certain raninids, Libinia emarginata and Mycteris platycheles, are capable of moving forward or backward, and others, particularly in the families Pertunity and Matutidi, have adapted their last pair of legs into natatory paddles, allowing them to swim very efficiently. Moreover, these crustaceans display complex behaviors, communicating through tapping or by moving their claws and, in competitive contexts, acting aggressively towards one another to gain access to shelters or mates. Their feeding is omnivorous, based mainly on algae but incorporating a variety of resources such as mollusks, worms, other crustaceans, fungi, bacteria, and detritus, which promotes optimal growth and adaptability in different habitats. The earliest crab fossils undoubtedly date back to the early Jurassic, when a primitive form called 𝐜𝐫𝐚𝐻 appeared, found in Great Britain. This fossil represents an ancestral line that did not yet have all the characteristics of modern crabs. During the Jurassic, most of the remains found are only the upper parts of their carapaces, which makes it difficult to know exactly how they were related. With the increase of coral reefs in the late Jurassic, crabs diversified, although their numbers declined when the reefs began to deteriorate. During the Cretaceous, these animals increased in diversity and became one of the predominant groups of decapods.
Modern crabs, classified in the Brachyura, are part of a group of crustaceans that are characterized by walking or swimming in some cases, and are grouped within the suborder Reptantia, which also includes lobsters and other crustaceans that move along the bottom. The Brachyura are closely related to hermit crabs, which belong to the group Anomura. Within crabs, the first evolutionary branch that separated is called Dromaeotia, which occurred many years ago in the late Triassic or early Jurassic. Later, during the Jurassic, other groups such as the Rhamnoidea and Cyclodoropoida emerged. Subsequently, in the Cretaceous, the main line divided into two groups, Heterotremata and Thoracotremata. Although debates still exist about the exact relationship between these groups, these divisions help us understand the great diversity and evolution of crabs over time. The Heterotremata constitute one of the two main groups of modern crabs. This group is characterized by differences in the position of the reproductive openings between males and females, which gives them their name. Within the Heterotremata, we find a great diversity of species that inhabit areas from coastal zones to freshwater environments, and they display a variety of shapes and sizes. Moreover, their evolution has been marked by adaptations that have allowed them to survive and thrive in different habitats, making them a fascinating group for the study of biodiversity and the evolution of crustaceans. Within the Heterotremata, the Neostringeria clade groups together a set of freshwater crabs endemic to Colombia, adapted to the particular conditions of high mountains. These crabs, known for their direct development and for exhibiting modifications in key structures such as the gonopods, are found in habitats ranging from 2,200 to 2,900 meters above sea level, mainly in the basins of the Magdalena, Orinoco, and Catatumbo. The evolution of this group reflects specific responses to environments with low temperatures and high oxygen levels, which translates into unique patterns of behavior and morphology. The study of Neostringeria not only enriches our understanding of the diversification of crabs within the Heterotremata, but also offers valuable clues about the evolutionary processes that allow the colonization of such demanding ecological niches.
Currently, records indicate that Neostringeria macropa is found in municipalities such as Tabio, Sopo, 𝐒𝐚𝐻, Zipaquira, Guatavita, 𝐜𝐫𝐷, Sesquil, Suesca, Chocanta, Villapinzan, and Tausa, located in the high plains of 𝐜𝐫𝐷 in Bogota, irrigated by the currents of the Checua, Bogota, and 𝐜𝐫𝐷 rivers. Recent studies have expanded its range, reporting its presence in the southern part of the Bogotá savanna, for example, in 𝐜𝐫𝐷, San Miguel village, near the banks of the Muna River, as well as in areas of the west, in regions of Facultativa and 𝐜𝐫𝐚𝐰. The species inhabits galleries associated with the margins of water bodies and has even been documented in environments with polluted waters, such as in the Bogotá River sub-basin. It behaves in a solitary manner, coming together only for mating, and shows marked sexual dimorphism, as females are smaller than males. Neostringeria macropa has considerable commercial value, being used in subsistence and artisanal fishing in lagoons, rivers, and streams for over 30 years, in addition to being part of aphrodisiac beverages known as 𝐜𝐫𝐴. Its ecological role is fundamental, as it contributes decisively to the decomposition of organic matter and the maintenance of soil health in freshwater ecosystems. However, the species faces multiple threats, such as deforestation in water basins, pollution from discharges, mining, urban development, wetland desiccation, habitat fragmentation due to dams, alterations in river flow, and the introduction of exotic species. These factors have led to Neostringeria macropa being in a critical situation, with an ever-reducing distribution range in the Bogotá savanna. 𝐵𝐴 is a traditional aphrodisiac beverage in some regions of Colombia, made from extracts of animals and herbs with supposed stimulating properties. In the case of the Bogotá savanna, it has been reported that one of its variants includes the Sabanero crab, Neostringeria macropa, which is crushed and mixed with aguardiente, honey, herbs, and other ingredients. It is believed that this preparation increases energy and virility, although there is no scientific evidence to support such effects. The consumption of 𝐵𝐴 is part of popular culture and ancestral beliefs regarding the benefits of certain natural products for sexual health. However, its preparation and commercialization have been the subject of debate due to its impact on biodiversity, as it contributes to the indiscriminate capture of endangered species such as the Sabanero crab.
The preparation and consumption of 𝐵𝐴, by including the Sabanero crab, Neostringeria macropa, can favor the transmission of zoonotic diseases such as paraganimiosis. This disease is caused by the parasite Paragonymous spp, a type of trematode, flatworm, that has a complex life cycle involving freshwater crabs as intermediate hosts. When people consume these crustaceans raw or undercooked, they ingest larval forms of the parasite Metacercariae, which then migrate to the lungs, causing severe infections. The custom of crushing the crab in beverages without an adequate cooking process increases the risk of infection, as the infective forms of the parasite are not eliminated. Under natural conditions, the biological cycle of Paragonymous maintains an ecological balance between predators and prey. The parasite completes its development in crabs or snails, which are consumed by natural predators such as carnivorous mammals. However, when humans alter this cycle by ingesting infected crabs in traditional preparations, they break the natural barrier between wild fauna and human populations, creating an aberration in the trophic chain. Instead of a specialized predator, humans become an accidental host of the parasite, which favors the occurrence of sporadic outbreaks of the disease in communities that practice this type of consumption. Paraganimiosis can manifest with symptoms similar to tuberculosis, including chronic cough, chest pain, and the production of bloody sputum. In some cases, the larvae migrate to other organs such as the brain, causing severe neurological symptoms. The difficulty in diagnosis means that many cases are mistakenly treated as common respiratory infections, which aggravates the patient's condition. Despite its relevance in public health, the risk of contracting this disease through the consumption of baraquilo remains little studied in Colombia, underlining the need for educational campaigns about the dangers of consuming undercooked freshwater crabs. Traditional practices such as the preparation of baraquilo have turned the Sabanero crab, 𝐜𝐫𝐚𝐬 macropa, into a fishing resource, despite its status as an endangered species. In many local communities, these customs are deeply rooted in cultural identity and subsistence economy, which generates tensions when authorities impose regulations for its conservation. Although scientists claim that Colombia has made progress in the protection and management of its natural resources, there remains a contradiction in the regulatory framework. In 2019, the National Aquaculture and Fisheries Authority, ONAP, approved a resolution that classifies the Sabanero crab, 𝐜𝐫𝐚𝐬 macropa, as a fishery resource, which allows its commercial exploitation. This decision becomes especially controversial when considering that the species is already listed as endangered, suggesting that its population could be compromised by overfishing and unsustainable extraction. The situation generates concern among conservationists and biodiversity experts, who point out that classifying N. macropa as a fishery resource could contradict efforts aimed at its conservation. This resolution, instead of reinforcing measures to ensure the species' preservation, might encourage fishing practices that worsen the decline of its populations. Thus, despite advances in the protection of aquatic species in Colombia, the lack of coherence in management policies threatens the long-term viability of this crab, emphasizing the need to review and adjust regulatory criteria to ensure a balance between exploitation and conservation.
This type of conflict reflects a broader problem regarding the use of threatened species in contexts of subsistence and culture. The hunting, fishing, or gathering of endangered fauna has been historically regulated in Colombia, but in many cases the restrictions generate resistance among communities that depend on these resources. For the inhabitants of the Bogotá savanna who have consumed baraquilo for generations, the prohibition without viable alternatives for livelihood can be interpreted as an unfair measure that does not take into account their economic reality. This has occurred with other endangered species, such as the 𝐜𝐫𝐚𝐽 turtle in the Caribbean region, whose hunting continues despite its legal protection, due to the importance of its consumption during local festivities. The discussions about the protection of 𝐜𝐫𝐚𝐬 macropa and its exploitation as a fishing resource illustrate the complexity of balancing conservation with cultural rights. A conservation approach that ignores the social context runs the risk of failure, while permissiveness without regulation can lead to the species' extinction. In this dilemma, the key is to develop strategies that integrate community participation, sustainable management, and environmental education. However, the economic and political power of the sectors pushing urban development in the Bogotá savanna has displaced many of these discussions to the background, leaving both the species and the communities that depend on it in a vulnerable situation. The other threats the species faces are intimately related to the development-focused approach of the Bogotá savanna, where urban expansion has drastically altered aquatic ecosystems. Historically, many of the wetlands that were part of the natural water network have been transformed into paved areas, eliminating essential water bodies for species such as 𝐜𝐫𝐚𝐽. This process has been driven by an economic model that prioritizes urban growth and infrastructure over environmental conservation. The conversion of rivers and streams into culverts, along with the channeling of key tributaries, has caused significant changes in the water balance, affecting not only the local fauna but also water availability for the population.
One of the most evident examples of this transformation has been the accelerated urbanization in municipalities such as 𝐜𝐫𝐚𝐽, Mosquera, and Funza, where wetlands and floodable lands have been replaced by large residential and industrial projects. This development has generated controversies between environmentalists and authorities, especially when construction permits have been approved in areas that have historically served as natural flood regulators. An emblematic case was the discussion about the protection of the 𝐜𝐫𝐵𝐴's wetland, where it became evident how the pressure from real estate sectors led to the relaxation of environmental regulations. Despite the existence of regulations that protect these ecosystems, the lack of effective enforcement and the power of the real estate lobby have allowed urban projects to be prioritized over the conservation of critical habitats. The impact of these decisions not only affects 𝐜𝐫𝐚𝐽, but has also had direct consequences on water availability in the region. The overexploitation of water resources, combined with the deforestation of basins and river pollution, led to the water supply crisis that resulted in water rationing in 2024 and 2025. This situation generated strong political controversy, with accusations exchanged between the government, construction companies, and environmental groups. While some argued that uncontrolled urban development had led to this crisis, others defended the need for housing expansion to respond to population growth. In this scenario, the situation of the Sabanero crab is not only an ecological problem, but a reflection of the tension between conservation and development, underlining the importance of a scientifically informed citizenry that demands responsible management of natural resources.